So these notes are going to start our thermochemistry unit after our discussion of heat versus temperature. So these are more formal notes for these topics. So heat, the symbol we're going to be using is lowercase q. And heat we're going to define as a form of energy that flows from warmer or hot to cold. And again, the energy we're talking about here is generally going to be kinetic energy, but you could also say that there is some potential energy possibly in there. So heat is going to be energy flowing from warmer to colder. So the units we're going to see for heat are as follows. So joule is a capital J, calorie is a lowercase cal, and then a big calorie, capital C, is the food calories we see on our boxes of any kind of food item that we buy manufactured. So that's going to be a capital CAL. And I'll show you the relationship between all of these. So a joule, 1 joule is equal to 0.239 calories. But the one we're going to use most often is going to be a calorie is equal to 4.18 joule. That's going to be the conversion that's going to be most common for the calculations we're going to be seeing. And then the big C, big food calorie is 1,000 little calories or a kilocalorie. And if you buy any food items that are coming from other places outside the United States, you will find that they sometimes list as kilocalorie instead of our big calorie. So what is a calorie? A calorie is the quantity of heat needed to raise the temperature of 1 gram of pure water 1 degree Celsius. So that's our definition of a calorie, is based off of pure water. So how much energy does it require to take just 1 gram of pure water up 1 degree Celsius? So again, degrees Celsius, what is that in terms of units or things that we're talking about? Well, that is what we call temperature. And temperature is going to be a capital T most of the time that you see it. It is the measurement of average kinetic energy of a substance. So kinetic energy, again, can be abbreviated KE, and it is the energy of movement. Okay, so everything is moving unless you're at absolute zero. So everything is going to have some kind of temperature. And the units that we are going to use, mostly in our discussion for thermochemistry, is going to be Celsius. We don't really do anything in Fahrenheit. And the other unit that we use is Kelvin, but we probably don't need to use it necessarily in thermochemistry. It's much more applicable in some other parts of chemistry. But temperature is the measurement of average kinetic energy. So talking about heat, we're going to talk about something called heat capacity and something called specific heat capacity. So heat capacity is a substance can absorb or give off a certain amount of heat. So it depends upon, again, the substance at hand. So what kind of substance do you get? So it's the amount of heat it takes to change a substance temperature by 1 degree Celsius. So it's heat over 1 degree Celsius, heat over 1 degree Celsius. So this heat capacity depends upon the mass of the substance. So it depends upon how much stuff I actually have, how much of the substance. Because if I have 100 grams of boiling water, okay, versus 1 gram of boiling water, one is going to have more heat because I have 100 grams versus 1 gram of boiling water. So like if I just took 1 gram of boiling water and put it on my hand, it would not hurt me that much, but 100 grams of water would. So heat capacity is going to show up in a couple cases, but it's not as useful as what we call specific heat capacity. Since it is heat over degrees Celsius, the unit is joules per degree Celsius, or you can see some of these units of calories. It's just we use joules more often, but you can have a calorie per degree Celsius for your unit of heat capacity. You could have that as well. So what is specific heat capacity? Well, specific heat capacity is far more useful for us, and you sometimes hear it abbreviated specific heat. The symbol we're going to use is a C, a capital C. Other books use SP and some other things for specific heat. So it just depends upon the author. It is the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. So what's going to be different about specific heat capacity is talking about 1 gram of a substance. So this unit is going to be joules, again, heat on the top, but then it's going to be per 1 gram per 1 degree Celsius. That's why it's joules per gram degree Celsius. It's going to be calories per gram degree Celsius, calories per gram degree Celsius. So that's going to be the unit we use most often is specific heat, specific heat.